In this recording, we are going to discuss the completion of assignment 4, which is on neural networks. This assignment will take information, which is financial information for various companies, and try to solve a binary classification problem, namely predicting whether or not a stock will pay out a dividend. This assignment is due on Friday, April the 1st. As always, the assignment consists of an assignment Dropbox where you submit your artwork and Moodle quiz assignment. And so those need to be completed on the Moodle page. This assignment uses a data set called dividend info, which is available on Moodle as a .csv file. We'll see this in a moment. So what you'll want to do is download the file and then load it in R. As always, use set.seed123 for results that are as reproducible as possible. Now, because we're working with a neural network, we need to normalize our data. Normally, we might use, say, standard normalization, such as z-scores. But in this case, our dividend variable, which is the target variable, is given by a 0, 1 variable. Right? So it's does it pay a dividend, yes or no? No would be 0, yes would be 1. And so because we have this binary classification variable as our target variable, we need to be careful about how we normalize. The problem with using standard normalization, so z-scores, is that will recenter the data 0. And then what will happen is it'll mess up our confusion matrices later. So instead, for this problem, what we're going to use is what's called max-min normalization. So you can implement this in R, and some of this is discussed on the assignment 4 hint file, and then store the normalized data as a data frame. Then what we'll do is form an 80-20 training testing split. Since the data is already essentially in a random order, we'll simply use the first 80% of the rows in the training as the training data and the final 20% as the testing data. What we're going to do is build a neural network in R on the training set and then test it for accuracy on the testing set later using a confusion matrix. What we'll do is we'll use the neural net package. So you'll want to have this loaded in R and use dividend as the target variable and the rest of the variables in the data set as the features. What we're going to do is create an initial deep neural network, and then we'll create some more ones later and compare. So what we want to do first is implement 2 hidden layers with 3 nodes at the first hidden layer and 2 nodes at the second hidden layer. We want to set linear.output to false, and this means that activation functions will be applied to the hidden layers, and set the threshold to 0.01, which means that if the change in error during an iteration is less than 1%, then the model will stop optimizing. What you want to do is test your model on the training set by generating a confusion matrix and then calculating the accuracy from the confusion matrix, as we've done on previous assignments. Finally, what we'll do is we'll essentially repeat the same process, but with slightly different neural networks. So what we want to see are 2 effects. First of all, if we maintain the same number of hidden layers, 2, but we increase the number of nodes, so the first hidden layer will have 7 nodes and the second will have 5 nodes, what does this do? And then we want to see what happens if we form a deeper network. So in this case, where we have 5 hidden layers that have 5, 4, 3, 2, and 2 nodes respectively. So then we'll run through the same process as in section 4, including the training and also the testing. Essentially then, once you've completed section 4, you can copy and paste your work there, changing the number of hidden layers and or nodes, and then also the names for the models as necessary. So if we jump back to the course page, we see assignment 4, the assignment, the Dropbox, and then the dividend info.csv file. So this is what you'll want to download in order to complete the assignment. Then there's the assignment 4 hints file, which will go through some of what you might want to use code-wise. In particular, it will describe the max-min normalization process that was discussed on the assignment 4 PDF file. let's take a look at the assignment for quiz, keeping in mind that the quiz and the Dropbox are both due by 11:59 p.m. on Friday, April the 1st. So question 1 on the quiz says, based on the confusion matrix constructed on the testing set, what is the estimated predictive accuracy of your deep neural network consisting of 2 hidden layers with 3 and 2 nodes? So this is asking for the predictive accuracy obtained by the confusion matrix. Question 2 says, what is the reported error and number of steps for your deep neural network with 2 hidden layers having 3 and 2 nodes respectively? So when you train the network, it will produce an output, which is essentially a diagram of the neural network, and it will tell you the minimum error achieved and the number of steps before it stopped training. So this, remember, is related to the threshold being 0.01, getting less than 1% improvement. So that will also be output in your R file. The next questions repeat questions 1 and 2 for the other 2 deep neural networks constructed. So question 3 asks for the estimated accuracy off the confusion matrix for the neural network with 5 hidden layers. And question 4 asks for the reported error and number of steps for the neural network with 2 hidden layers, but having 7 and 5 nodes. So you notice these questions are in somewhat of a random order. Question 5 asks for the accuracy from the confusion matrix for that deep neural network having 2 hidden layers with 7 and 5 nodes. Question 6 asks for the reported error and number of steps for the deep neural network with 5 layers with the given numbers of nodes. Question 7 asks you to compare. Based on your answers to the previous questions, comment on the apparent effect, positive, negative, or neutral, of increasing the number of hidden layers and or nodes on the accuracy of the model. Basically, compared to the first neural network that we constructed, do we see any improvement by increasing the number of nodes while maintaining 2 hidden layers, or by increasing the number and or by increasing the number of hidden layers from 2 to 5? Finally, question 8 asks you to explain what you've done in a non-technical way. A hedge fund manager commissions you to provide a report summarizing your model and how it makes predictions on whether or not a stock the hedge fund invests in will pay a dividend. In particular, the manager wants you to estimate the probability that the stock you predict will pay a dividend actually does so. Write a 1 to 2 paragraph summary for the hedge fund manager. You may write your space in the summary in the space provided, or attach a file if the length exceeds the maximum provided space. So what you'll want to do here is explain how the model works, your different models work, and what does the estimated predictive accuracy mean in terms of how accurately a job does at predicting whether or not a stock will pay out a dividend. So you may, as mentioned, there is an assignment for a hint file for you to look at. You might find that very useful, or maybe not. If you have any questions related to the hint file or anything else you want to do on the assignment, please let me know and I'll be happy to help you.